Alright, Assalamu alaikum. This is Talhavi Nadeem, and this is the second video lecture uh, of the topic lubrication and lubrication systems. In the first video of this topic, we basically studied regarding the lubrication, and we started off with the basic with the basics of the lubrication system, that why do we even require the lubrication, and what are the functions of a lubrication, what are the requirements of the lubrication system. And after that, we basically started the different properties, the desirable properties of a lubricant, and we studied these properties in quite some details. And I also mentioned that what are the desirable properties of the lubricants, that for example the flash point and the fire point temperature of a lubricant should be high, and the cloud point and pour point temperatures should be low, oiliness should be high, it should have a higher anti-corrosive characteristics, etc. So after the brief discussion, in fact after the very detailed discussion regarding the desired properties, we started off with the we started off by saying that in order to achieve such properties, we cannot achieve those properties in a naturally occurring lube based oil. So we have to add some additives, and then we discussed that what additives are usually added uh, to achieve the desired properties. And we studied these additives in quite some details, that why these additives are being utilized. So after concluding the different additives which are being used, we move towards the different types of a lubricants, and we studied that in broader sense the lubricants can be classified into two categories: oils and grease. Then oils can be further classified into four categories: mineral oils, fatty oils, synthetic oils, and multigrade oils. And we discussed these three categories in quite some details. And before starting off the multigrade oil, I briefly discussed the introduction. I gave the introduction regarding the SAE, which is the Society of Automotive Engineers, and we discussed about what does this 5W means and what does this 20 mean. And then we discussed the multigrade oil, that these oils will have the multiple properties. These oils will behave like two different oils when operating at when they are operating at winter conditions. They will behave like 5W, but when they are operating under in summer conditions, they will operate like a 20 grade SAE 20 grade oil. Then we also studied the brief introduction regarding the grease, why are they being used, and what are the advantages of using the grease, and what are the limitations of using the grease. Because we will not because in engines we cannot use grease for the lubrication, but for the sealing purposes in our IC engine, we usually prefer we use greases because they require lesser attention from the maintenance point of view. And now today I am going to start off with the topic of the lubrication system. And before moving towards the lubrication system, I would like to share a video that why the lubrication and lubrication systems are important for our IC engine. Okay, now I'm going to start off the video.
Modern engine oil. Incredible engineering that enables incredible performance. By lubricating the engine, the oil isn't simply keeping it running smoothly, it's protecting it and preventing damage. Oil begins its journey in the engine's sump, a reservoir of oil.
Okay, here it is mentioning that the oil is present in the oil sump of a car, and from the oil sump it travels across across those parts of the engine where the lubrication is required.
From here, it gets pumped around the engine. The oil pump is vital to the life of the engine.
So oil pump is basically that equipment which is pumping this oil from the oil sump to the parts of the engine where the lubrication is desired.
It sucks oil up from the sump through a pickup tube, pressurizes it, and sends it around the entire engine through a circuit of oilways. From the pump, the oil travels to the oil filter, which removes microscopic particles and supplies clean oil to the rest of the engine.
Okay, it is showing that this oil pump before sending this lubrication oil to the engine, it basically passes it through the oil filter, where this oil filter basically removes the particles, some metallic particles maybe, or may have some dust or grit particles. It might have some soot particles as well. It will remove those particles, and then that lubrication oil will go to the engine for the lubrication.
Clean oil flows to all the critical engine parts. The bearings, supporting the crankshaft on a continuous film of oil. Pistons, cooled down and kept clean by the oil's detergent action. And the valve train, protected by the oil's anti-wear system.
Means that lubrication oil is basically going to the bearings of the crankshaft. It is also going for the lubrication in the piston and the cylinders, and also your valve train is being lubricated by this lubrication oil. All of these are moving components, rotating and reciprocating components, so lubrication is necessary in these components. Therefore lubrication is required between these moving components.
Loads in the valve train are the highest in the engine. This is where the oil experiences the most stress. To avoid friction and damaging wear, these fast-moving metal components must be lubricated.
Okay, one very important factor which here is mentioned, that oil basically experience the highest mechanical stresses where we have the valve train, and your oil should have that much film strength, that much oiliness, so that it can bear all the mechanical stresses which are occurring in the valve train.
The oil is the only thing preventing metal-to-metal contact.
So as I mentioned earlier, as I explained earlier in the last video, that oil is basically forming a film between the two contacting metal parts, and it is the only thing which is avoiding the metal to metal contact. If the oil film breaks and metal to metal contacts, as a result we can have a drastic effect on our engine, and we can have a wear and tear in our engine, and our engine may get damaged.
Returning to the sump via oil return channels, the oil completes its journey. This whole journey can take as little as 5 seconds.
So after the lubrication, this oil will again come back to the oil sump, and usually it only takes 5 seconds of the duration for the oil to travel across the engine.
Throughout the oil's journey, its primary function is to protect. It does this in many ways, reducing friction and metal-to-metal contact.
So again, It is mentioning some of the functions of this lubrication and lubrication system, that it reduces the friction,
reducing wear throughout the drive, and reducing harmful deposits.
it reduces the wear and tear, and it also reduces the harmful deposits between the moving components of an IC engine.
Regular maintenance with a quality oil and filter will protect and preserve the heart of the car, the engine.
So regular maintenance or regular checking of the lubrication oil can result in better performance of your engine. It will avoid the damages of your IC engine.
Bring it running at its best for longer. It's more than just oil. It's liquid engineering.
So uh, as it is mentioned in this video, that it is more than just oil, it is liquid engineering. So yes, that is that is totally true, because a term tribology is being used for this engineering. Tribology is only related to the lubricating oils and the particles which it takes during the lubrication along with it. So tribology is that term, that field, that engineering field which is related to the lubrication oils. Now, so all right, now I'm going to start off with the details of the lubrication system. Starting off with the introduction. So the main parts of an IC engine which needed the lubrication are as follows. As I have shown you in the first video, that your IC engine needs to lubricate the bearings of the crankshaft, and it should lubricate the piston in between surfaces of the piston and cylinder. Then it should also lubricate the cam drive as well, which includes the camshafts, cam bearings, and the valve mechanism. So these are some of the basic components of an IC engine which require proper lubrication. So the following components are main crankshaft bearing. They in the IC engine we do not have a bearings like a roller bearing or a cylinder bearing, but we have journal bearings in our IC engine. I will show you how these journal bearings look like. Similarly, we have the big end bearing and the small end bearing. Big end bearing and small end bearings can be seen as, for example, if this is my connecting rod, and here this is our small end bearing, and here this is our big end bearing. Next, it should also lubricate the piston ring and cylinder walls. It should lubricate the timing gears, the camshaft and camshaft bearings. It should also lubricate the valve mechanism, valve guides, valve tappets, and the rocker arms. So all of these things are called basically the cam drive. Means these are the equipment, these are the components which would be opening and closing the valves. This is particularly related to the piston and cylinder walls, while this is related to crankshaft and the connecting rods. Now moving forward, before starting the different types of the lubrication system in IC engine, I would like to share another video another video in which will give you a better concept, which will give you a better visualization that how this lubrication is going to be done, in the IC engine.
Engine lubrication by means of oil is primarily used to reduce friction between moving parts and dissipate heat.
Now here you can see so far it has just explained the function of the lubrication, that it has to provide a lubrication and has to cool the engine as well. Now here you can see some of the basic components of a lubrication system. Like here, this is our oil sump, and here this is our oil pump, this is the oil cooler, and maybe by means of air or maybe by means of water it would be cooling the lubrication oil. And then we have this oil filter. Now moving forward,
In this animation, we want to describe wet sump lubrication using a 4-stroke engine with only one cylinder.
now again in this video it is basically explaining the wet sump lubrication system. So as I mentioned that I will discuss all of these classification, all of these types of the lubrication system in quite some detail. We just left that wet sump lubrication system part. This video is just to give you the basic concept that how the lubrication is actually being done.
In the lower area of the engine is the oil sump in which the oil can be found.
Now in the lower area of our IC engine, I have explained, I have mentioned this part quite sometimes, that we have the oil sump in which the oil is present.
The oil pump is responsible for pumping the oil through oil galleries.
So now this is our oil pump. This is our oil pump. It is basically taking it is responsible for taking the oil from this oil sump into the necessary portion of the of our IC engine where the lubrication is required.
When the oil has become very hot after several cycles, it is cooled by an oil cooler.
Now after several circulations of this oil, its temperature increases. Because of the increment in the temperature, we might have some loss in the properties of the oil, so we have to cool that oil, and for that purpose we have added oil cooler here.
The oil is then pumped to the oil filter.
And after the oil cooler, it is being pumped into the oil filter. Now this is very interesting thing about that how this oil filter is going to filter the oil, and it will remove the metallic particles, dust and grit particles, or it may have some soot particles as well. How this filter is going to remove it, it is very easy to understand through this video.
Inside the oil filter is a filter that catches the particles in the oil and does not allow them to pass through to the engine.
Now here you can see that this oil filter is not allowing the metallic particles and some other dust, grit particles and soot particles to pass through this filter, into the IC engine. Otherwise, these particles will act as an abrasive material between the two rubbing surfaces and will cause wear and tear in our IC engine.
The oil flows from the outside into the oil filter, then runs through the filter, which is made invisible here, and flows through the center tube. Then the oil flows upwards.
Now it is very necessary to understand here that oil is basically coming from the top, from the sides of this oil filter, and then the level will rise and it will go outward from the center of this oil filter. As you can see, we have these passages, circular holes. From here it will go into that circular section.
The oil flows to the engine where it is used to lubricate the crankshaft bearings. In four-stroke engines, crankshaft bearings are almost always plain bearings.
Now, as mentioned, that in four-stroke engines, crankshaft bearings are most of the time the plain bearings, or we can say the journal bearings. These bearings are not like the conventional roller bearings, roller element bearings, or cylindrical element bearings. Here in this animation, you can clearly see. You will understand how these journal bearings look like and how do they operate.
Unlike roller bearings, which use roller elements to move the inner and outer ring against each other, plain bearings use oil to form a lubricating film. The lubricating film is created by the two contact surfaces that move.
Now it is very I hope it is easy to understand now, and most of you guys would have visualized it, that how plain bearings operate. We as it could have been seen from the side view that there was a circular passage which was provided for the lubrication oil to come, and it will form the thin film in between these two rotating surfaces. So in our crankshaft we can see these holes, these passages for the oil, and these bearings are basically known as the journal bearings, because we do not have any sort of a rolling element here. Instead, we have a thin oil film in between the moving surfaces.
The crankshaft has oil galleries so that the connecting rod bearing can be supplied with oil.
Now, here you can see this crankshaft has some oil galleries, means there will be some oil passages, because we have to provide the oil for the lubrication to the connecting rod, to the crankshaft as well. So oil will pass through these oil passages and it will lubricate the big end bearing. This is the point where we have the big end bearing, because the connecting rods big end is connected to the crankshaft. These bearings are also journal bearing.
In diesel engines, the connecting rod can also have an oil gallery to use the oil for cooling and lubricating the piston and the piston pin.
And here you can see that connecting rod may also have a passage from where the oil will go up, and it will lubricate the small end bearing and the connecting pin from which the piston is connected to the connecting rod.
For gasoline engines, on the other hand, the oil, which splashes out of the sides of the bearing, is used to cool and lubricate the piston, pin, and cylinder. This can also help to transport the oil to the desired parts and spots.
Now, this is very important thing to understand here, that in gasoline engines we usually do not have these oil passages through the connecting rod which will go up and lubricate this gudgeon pin, or you can say a small end bearing. What happens in the gasoline engine, they have provided some small passages, and because of the movement of this connecting rod, and the oil basically splashes up, and it will lubricate the small end bearing and the piston and cylinder walls, as it can be seen in this video.
The piston has one or two compression rings and one oil scraper ring. The oil scraper ring is responsible for controlling the oil balance at the piston and the compression rings.
As we have studied so far, that usually in pistons we have two compression rings and a oil ring. This oil ring is basically not allowing the oil to go pass through this section, otherwise it will it may get a more chance or a probability to get inside the combustion chamber, and may result in the incomplete combustion and reduction in the lubrication oil level as well. This lubrication oil ring ensures that all of the oil is being scraped off from the surfaces of the cylinder, and some of the oil may get here in this section where it will lubricate the crank pin and the piston as well, crank pin and the small end bearing of the piston.
Excess oil flows inwards through holes, especially when the piston is running down. Then, the oil can drain down from the piston into the oil sump. Furthermore, the oil is pumped to the camshaft bearings, rocker arms, and valves in order to reduce friction and heat.
So as it can be seen that the cam drives are also being lubricated with this lubrication oil, and they are being pumped upwards to lubricate the cam drives, which includes camshafts, these rocker arms, and the whole valve mechanism.
From here, the oil flows into the oil sump via oil galleries.
So I hope this would be clear to all of you, that how these lubrication systems usually work, and how this lubrication oil is sent to deliver to all the basic components of an IC engine for lubrication. Now moving forward, as I mentioned earlier, that we basically have three different types of the lubrication system in our IC engine. The first one is the wet sump lubrication system, and we have further classified this wet sump lubrication system into three more classification. The first one is splash type lubrication system. The second is splash and pressure type lubrication system. Sometimes it is also referred as semi pressure lubrication system. And the third is pressure feed lubrication system. So this is what we are going to start now. As the name suggests, that the oil sump in the wet sump lubrication system will consist of a lubrication oil. Now here you can see in the wet sump lubrication system, the bottom of the crankcase contains an oil pan, or you can say oil sump. from which the lubricating oil is either pumped, okay, now I'm using a word, either pumped or splashed. Means we may have a splashing phenomena or maybe some pump which will pump the liquid oil from this oil sump to the other portions of a IC engine, to the other various components of a IC engine. After lubricating these parts, the oil will flow back to the sump to the sump by gravity, and I have shown this thing in the video I just explained earlier, that oil after lubrication will come back to the oil sump, and again it is picked up by a pump and recirculated through the engine lubricating system. This engine lubricating system may contain of a oil cooler, oil filter, and after passing through this oil lubrication system, it will again repeat the whole cycle, whole process. There are three different varieties in wet sump lubrication. The first one is splash lubrication system. So starting off with the flash lubrication system, here you can see this is the schematic of a flash lubrication system, and here you can see we have this crankshaft. This is our main bearing in the crankshaft. Here we will have the big end bearing, and this is our small end bearing. These are the camshaft and the connecting rod. These are our connecting rod bearing. Here we will have the connecting rod bearing as well. In this diagram there is only one piston shown on the crankshaft. However, from the figure we can see that we may have more pistons here as well. As you can see that here we have an oil trough as well, and in this oil trough, this is known as splasher. This pin which is present in between below the crankshaft, below the connecting rod, is called either splasher or maybe sometimes also written as dipper, because when this crankshaft is operating, when this crankshaft is reciprocating, this connecting rod is reciprocating, what happens is this big end section of the connecting rod will move up and it will come down, and this dipper will splash the liquid lubrication oil which is present inside this oil trough, and that lubrication oil after splashing will move up and it will lubricate the components of the IC engine. So as you can see that the lubrication is dependent on the level of the oil which is maintained in the oil trough, and on the splashing, how effective the splashing is. So therefore these type of systems are generally limited to very small and stationary IC engines, and they are not generally being incorporated in the modern IC engines, modern cars, we can say. They are not usually incorporated. So starting off with some of the discussion, this type of a lubrication system is used in the light duty engines. The lubricating oil is charged into the bottom of the engine crankcase and maintained at a predetermined level. Then the oil is drawn by a pump and delivered through a distributing pipe extending the length of a crankcase into the splash trough located under the big end of all the connecting rods. Here you can see this is our oil pump, and what this oil pump is doing, this oil pump is basically pumping the oil to these oil troughs. and it is maintaining a certain level in these oil troughs so that effective splashing can occur. So these troughs are provided with the overflow. In case of a overflow, they will provide the excessive oil back to the oil sump, and the oil in the trough are kept at a constant level. Now here you can see a splasher and or we can say a dipper is provided under each connecting rod cap, and you can see in the figure as well. This is our dipper splasher, as I mentioned earlier, which dips into the oil in a trough at every revolution of a crankshaft. As the crankshaft rotates, the connecting rod will move up and it will come down. So as a result, when it comes down, the splashing will occur and lubrication oil will splash upwards for the lubrication. And the oil is splashed all over the interior of the crankcase, into the pistons and onto the exposed portions of the cylinder walls. A hole is drilled through the connecting rod cap, through which oil is passed to the bearing surfaces. Now here in such portion here, for example, like here, a hole would be driven from where the oil will go into the these journal bearings of a connecting rod, where it will provide the lubrication to these bearings, to these journal bearings, as it was shown in the video I shared with you earlier. Oil pockets are also provided to catch the splashing oil all over the main bearing and also over the camshaft bearings as well. From the pockets, the oil will reach the bearing surface through a drilled holes. The oil dripping from the cylinder is collected. Now the oil which is coming back from the cylinder is then collected in the sump, where it is cooled by air flowing around. The cooled oil is then recirculated again. We might have a cooling system which includes a water, but since these engines are of very small sizes and stationary, therefore usually air is being used for such sort of a lubrication systems. So I hope it is clear to all of you what these splash lubrication systems are. Moving forward, we have the second type of a wet sump lubrication, and that is splash and pressure type lubrication system. These lubrication systems, are more effective than the splash type lubrication system, and they are less costly as compared to the pressure feed lubrication system. Similarly, they can enable the higher bearing loads, and higher engine speeds can be employed as compared to the splash lubrication system. So in here you can see in these lubrication system that again we will have the oil trough from where the here you can see that the oil is coming from this oil pump, and then here from this pipeline it is being pumped to the necessary portion of the of our IC engine. So for example, where the lubrication oil comes here and then it is being sprayed here for the lubrication. Similarly, in the bottom you can see there is a passage, it is coming, and then it is spraying the lubrication oil here for the purpose of lubrication. And we may have a small passage through this connecting rod from where the lubrication oil will go into the small end bearing for the lubrication as well. So this is how these lubrication system works. Means it does not only depend upon the splashing, but we also have an oil pump which is pumping this lubrication oil to the essential components where the where lubrication is required. So this type of lubrication system is less costly to install as compared to the pressure systems. It enables higher load bearing and engine speeds which can be employed as compared to the splash lubrication system. In this configuration, the lubricating system is supplied under pressure to main and camshaft bearing. Means oil is being supplied with the help of a oil pump to the main and camshaft bearings. Oil is also supplied under pressure to pipes which direct a stream of oil against the dippers on the pig end bearing, and then this lubrication oil, after it is being sprayed here to the dipper, and then this lubrication oil is will splash and will move upward for the lubrication in the essential parts, let's say between the cylinder walls and the piston. And thus the crankpin bearing are lubricated by splash or spray of a oil. So this is all about the semi pressure type or splash and lubrication splash and pressure lubrication system. Means in this system we are not only relying on the splashing, we also have incorporated the oil pump, and it is pumping the oil for the lubrication in the essential components. The main bearing and the camshaft bearings are being lubricated by the oil which is being supplied by the oil pump, and then the we can say the big end bearing and the crankpin bearings are being lubricated by the splashing or the spray of a oil. And in the last, this is the last type of the wet sump lubrication system, and it is of the pressure lubrication system. In these pressure lubrication system, we are not relying on the splashing, rather we only have the pressurized pipes which will provide the lubrication oil to all the essential parts of the lubrication system. Now here you can see from the figure that this oil pump is supplying the lubricating oil to the main bearings of the crankshaft, and not only the main bearings of the crankshaft, but also here you can see we have the oil passages. From these main bearing of the crankshaft, the oil is flowing through these passages into the big end bearing of the connecting rod as well, and through these passages the oil will move up for the lubrication in the small end bearing as well, where the crank pin is connected, and it will also lubricate the surfaces in between the cylinder and the piston. It will also supply the lubrication oil for the pumping. And you can see here that in the cam shaft as well it is supplying the lubrication oil. So the video which I basically shown you earlier had incorporated this type of a lubrication system where we had pumped the lubrication oil to the essential parts of our IC engine. So these passages are very important because they would be providing the lubrication oil and they are being incorporated in the designing of the crankshaft. So after the lubrication, this oil will again come back by gravity to this oil sump. So this type of lubrication system finds favor from most of the engine manufacturers, as I mentioned earlier, that these type of lubrication systems are being used most commonly by the engine manufacturers. as it allows higher bearing pressure and rubbing speeds. So in this configuration, the lubricating oil is drawn from the sump and forced to all the main bearings of the crankshaft through the distributing channels. And we also have a pressure relief valve uh, which is being fitted near the delivery point of the pump. In case if there is excessive pressure rise, so this valve will open and it will relieve the excessive pressure to ensure that we do not have any failure in the lubrication system. Otherwise it will cause a damage to our IC engine. An oil hole is drilled in the crankshaft from the center of each of the crank pin to a certain to a center of the adjacent main journal, through which the oil can pass from main bearing to the crank pin bearing, as I have shown you earlier. These are the passages which we were talking about, that it is providing the oil from the main bearing to the big end bearing of the connecting rod. From the crank pin it reaches the piston ring bearing through a drilled hole in the connecting rod. Here you can see that from here there is a hole which is being drilled inside the connecting rod, and from here it will go to the piston ring section, where it will lubricate the journal bearing of the piston ring. The cylinder walls, tappets, piston and piston rings are lubricated by oil spray from around the piston pins and the main and connecting rod bearings. The basic components of wet sump lubrication systems are pump, which will take the oil from the oil sump. Then we have a strainer, we have a pressure regulator, a filter and a breather as well. So these are the three basic types of the wet sump lubrication system which are generally being used. I hope it is understandable to all of you. I will show you the video regarding these lubrication system by the end of this lecture. So in case if someone still does not have a clear concept regarding it, will be able to understand it by the end of this video. Now moving forward, next we basically had, here you can see, we had two different types of the arrangement. The first one is the dry sump lubrication system, and the next is the mist sump lubrication system. Starting off with the dry sump lubrication system, here you can see if we look through the schematic of the dry sump lubrication system, here you can see that we basically do not have the oil pan here. Instead of having an oil pan, we have a separate storage tank for the lubrication oil, and from that separate storage tank, this scavenging pump will take the lubricating oil after passing it through the strainer, and then it will pass it through the filter where all the undesirable particles are being removed, and then it will go into the supply tank, and here the lubrication oil will stay. And after that, this oil pump will take the lubrication oil from the supply tank, and it will pass it through the oil cooler and then into the bearings of the crankshaft, and we can say to the entire IC engine, where it will provide the lubrication, and after providing the lubrication, it will again come back to this storage tank, where it will again repeat its cycle. It will pass through the strainer and the scavenging pump will again pump it to the supply tank, and then oil pump will take it from the supply tank and pass it through the oil cooler to cool it, and then into the IC engine for the lubrication. So this is how these engines would be operating. These lubrication systems are operating. So here you can see that we have a separate storage tank for the lubrication oil. Therefore these type of systems are known as the dry sump, because we do not have a oil in the sump. In this in these type of a lubrication system, the supply of oil is carried in an external tank. An oil pump draws oil from the supply tank and circulates it under pressure to the various bearings of the engine. Oil dripping from the cylinders and bearing into the sump is removed by a scavenging pump, which in turn to the oil is passed through a filter and is fed back to the supply tank. So here you can see that after the lubrication, the oil will come back to this storage tank, where it is being pumped by the scavenging pump into the supply tank, and then from the supply tank, oil pump will take the lubrication oil and will pump it to the IC engine, to the essential components of the IC engine, by passing it through the oil cooler as well. In this system, a filter with a bypass valve is placed in between the scavenge pump and the supply tank. So the purpose of this filter bypass is that, for example, this pipeline would be completely filled with the lubrication oil, but since this valve is not open, so it is not providing any lubrication oil. But for example, if this filter somehow gets clogged, now the entire pressure would be coming here in this pressure relief valve, and it is a spring loaded pressure relief valve, and when we have a very high pressure forces applied here, this spring will compress and this valve will be opened, and as a result the oil will come from here. So instead, even if our filter system is not operating properly, the lubrication system will operate properly, and it will avoid the damage to our IC engine by providing the lubrication system, even if our filter is clogged. So and we have a separate oil cooler with either water or air as a cooling medium, and is usually provided in the dry sump system to remove the heat from the oil. I hope all of you must have understood the basic concepts of the wet sump lubrication system, dry sump lubrication system. Now moving forward towards the last type of a lubrication system, and that is of the mist lubrication system. These lubrication systems were generally being used in a two-stroke engine, and in such cases, in two-stroke engines, we cannot have a crankcase lubrication system because compression is being done inside the crankcase. So what we do is we basically mix the oil with the gasoline, and so if you remember that if in anybody's home you may have some old Vespa or a Kawasaki motorcycle, what they do, they basically add some amount of a lubrication oil along with the fuel. And that the amount is approximately about 2 to 3% of the gasoline. So this type of a system is used where crankcase lubrication is not suitable, and in two-stroke engines, crankcase lubrication is not suitable because compression is being done in the crankcase. So in two-stroke engine, the charge is compressed in the crankcase, so it is not possible to have a lubricating oil in the sump. Hence, mist lubrication system is adopted in practice. In such engines, the lubricating oil is mixed with the fuel. The usual ratio is being 2% to 3%. The oil and fuel mixture is inducted through the carburetor. The fuel is vaporized and the oil in the form of a mist, this will not be listed here, it will be a mist. So the oil in the form of a mist goes via crankcase into the cylinder. The oil will strike the walls of the crankcase and it will lubricate the main bearing and the connecting rod bearing. And the mist of the oil lubricates the piston as well, piston ring and the cylinder. So this is how the lubrication in two-stroke engines are being done. The advantage of these systems are that they are very simple and they are very low costly as well. But the disadvantages of these systems are far greater. They release heavy exhaust smoke because of the partial burning of the lubrication oil, and since we know that oil is coming in close contact with the combustion product, so as a result our lubrication oil gets contaminated and may result in the corrosion of the bearing surfaces as well. So this system requires a thorough mixing as well for the effective lubrication, and no one can ensure that the fuel and oil is being mixed thoroughly. Similarly, during the closed throttle operation, when the lesser amount of the fuel is being provided, so the problem will occur that our engine will suffer from the insufficient lubrication because a lesser amount of the fuel is coming into our engine, so lesser amount of the oil is coming to our engine, so we may have a insufficient lubrication in such cases. So I hope these lubrication systems are clear to all of you. Now I will share another video. This is the last video of today's lecture, and after that we will conclude the topic of the lubrication and lubrication systems. So starting off with the types of a lubrication system, I hope you guys will listen carefully to this video. In case if someone does not have a clear visualization regarding it, will get a very good visualization after watching this video.
Hey guys, welcome back to the channel. In our previous videos, we have had a brief discussion about the lubrication systems. In this video, we are going to discuss the types of lubrication systems. As discussed, engine lubrication systems can be divided into three types. They are the mist lubrication system, wet sump lubrication system, and dry sump lubrication system.
As I explained that we have three different types of a lubrication system as mentioned in this video.
Let's start with the first type, the mist lubrication system. This type of lubrication system is used for two-stroke engines. The lubrication process is achieved by adding 2 to 3% of lubricant to the fuel. Here the carburetor takes in the oil-fuel mixture and the mixture gets introduced into the engine. Inside the engine, the fuel gets vaporized, but the oil in the form of mist deposits over the bearings and lubricates them. Some oil moves along with the fuel inside the engine cylinder and lubricates the piston and the cylinder. You might have seen people adding oil to the petrol tank in the older models of TVS 50. It is because they employ a mist lubrication system. This type of...
So I hope it is you guys may have a very good concept now after watching this video, that with the addition of the petrol we also add some amount of the lubrication oil for the lubrication in these type of a system, and this lubrication oil moves throughout the engine to lubricate it.
Lubrication system is simple and it is of less cost, but there is a chance of oil burning inside the engine. It results in high lubricant consumption and it also forms deposits over the cylinder surfaces which are not desirable. The next type of lubrication system is the wet sump lubrication system. This type of lubrication system consists of an oil sump located below the crankcase. The oil is taken from the sump for lubrication and the excess oil returns to the sump by gravity. Wet sump lubrication system can be further classified into three types. They are splash lubrication system, semi-pressure lubrication system, and full pressure lubrication system.
So as I mentioned earlier, that wet sump lubrication system will have a sump which consists of oil, and there are three different arrangements of the wet sump lubrication system. I have explained these different arrangements.
Let's start with the splash type. This lubrication system consists of a sump, strainer, oil pump, and an oil trough. In this type of system, the caps of the connecting rods are provided with a scoop and there is an oil passage drilled in the connecting rod. The oil from the sump is filtered by the strainer and pumped to the trough by the sump.
Here you can see that the oil is being provided by this oil pump into these oil troughs, and there is our splasher or dipper, we can say, that as the crankshaft reciprocates, this splasher will splash the oil in this oil trough.
The crankshaft rotates, the scoop dips into the oil trough, which makes the oil splash. The splashing oil lubricates the piston and the cylinder walls. Meanwhile, the oil enters through the drilled passage for lubricating the bearings. After lubrication, the excess oil returns to the sump. This type of lubrication system is used only in small stationary engines. The problem with this type of system is that it depends on the lubricant level in the trough. Less amount of lubricant results in failure, whereas high amount results in overconsumption of lubricant. Now let's move on to the
I explained this part that the level of the oil trough is very important. If we have excessive amount of oil in the oil trough, it will be overflowed and will send back to the oil sump. But if we have a lesser amount in the oil trough, it will result in the inefficient lubrication.
Next type, the semi-pressure lubrication system. As the name suggests, in this type, a part of the components are lubricated by oil splash and the remaining are lubricated by pressurized means. In this type, the oil from the sump is filtered by the strainer and pumped by means of an oil pump. The oil is directly pumped into the lines for lubricating the main and camshaft bearings. On the other hand, the remaining parts are lubricated by means of an oil splash or by nozzles. This system also has an oil pressure gauge which indicates whether the oil supply is sufficient or not.
So as it can be seen from the diagram that oil is being provided through these oil passages to the main bearings, whereas the other parts, let's say the big end bearing and the small end bearing and the piston and the cylinder, are being lubricated by the splashing.
Parts are lubricated by the system works comparatively better than the splash type. The next type of wet sump lubrication is the full pressure type system. The complete system is lubricated by means of a pressurized pump. Instead of splashing, a hole is drilled in the connecting rod through which the oil enters from the lower end to the upper end for lubrication. This system can supply the lubricant at a pressure of 1.5 to 4 bars, and it is preferred by most of the manufacturers. Well, that's all about the types of wet sump lubrication. Now let's move on to the last type in the main classification, which is the dry sump lubrication system. This system has a storage tank located outside the engine block. Here, the oil returns to the tank by means of a pump and not by gravity. It consists of a sump, a scavenging pump, a filter bypass valve, a storage tank, a pressure regulator, an oil cooler, and an oil pump. The oil from the sump is pumped by the scavenging pump and then filtered by the filter. The filtered oil enters the storage tank, where it is pumped by the oil pump for lubrication. The filtered oil enters the storage tank, where it is pumped by the oil pump for lubrication. The oil from the pump is cooled by the oil cooler before it moves for lubrication.
As I mentioned earlier, that oil is present in this dry sump, and from this dry sump, this scavenging pump will pump the oil to the storage tank, from where the oil pump will pump it through the oil cooler into the IC engine, where it will lubricate, and after lubrication it will come back to this dry sump.
This system can supply the oil at a pressure of 3 to 8 bar, and the pressure relief valve is used to relieve the excess pressure. The function of the filter bypass is to ensure oil movement in case of any clog in the filter. This type of lubrication system is used in heavy-duty engines and high-performance vehicles. Well, that's all about the type of lubrication systems. Wait for more interesting videos in the upcoming days.
So this is all about the lubrication system. I hope all of you must have understand the basic concepts of the lubrication and lubrication system. Try to view this video very carefully. In case you have any question, just note down your question and you can ask me in the online session, or maybe in the WhatsApp group, or the Google Classroom. Until the next video, Allah Hafiz.